When night falls, look up at the vast expanse of the sky. Every tiny speck of light you behold isn't just a pixel, it's a distant sun. Among these countless suns, many have existed longer than our own sun, and even more astonishingly, most of them possess their own planets. Today's cosmic science has unveiled a stunning truth. Our Milky Way galaxy alone is home to approximately 400 billion stars. And even more astonishing, most of these colossal suns are not alone. They are surrounded by complex planetary systems. Just imagine, this means there could be trillions of planets diligently orbiting countless suns scattered throughout the Milky Way. Among them, some planets might be solid, rocky worlds similar to our Earth, while others could harbor vast oceans, dense atmospheres, and even ideal temperatures for life to flourish. Now let's ponder another factor, time. Our galaxy, the Milky Way, has undergone more than 10 billion years of formation and evolution. Meanwhile, our planet Earth only appeared about 4.5 billion years ago. And human civilization is but a fleeting moment in the cosmic timeline. From a cosmological perspective, our presence is an extremely late event. If the hypothesis that life can spontaneously arise on planets and gradually evolve into intelligent forms is true, then surely, among those billions of star systems, brilliant civilizations must have emerged millions, or even billions of years before humanity appeared. This means they would have had an unimaginably long period to develop advanced technology, conquer the stars, and expand their empires across the galaxy. Yet as we cast our gaze into the vast universe, a chilling truth emerges, something profoundly unsettling. Not a single signal from other civilizations, no trace of intergalactic empires, no probes, not even strange visitors. Only a terrifying silence remains, a vast stillness so profound that it has sparked one of the most perplexing and frightening questions science has ever faced. If this universe is inherently teeming with diverse life, then where are they all? To truly grasp the haunting nature of this question, we must turn back and contemplate the overwhelming scale of the very galaxy we inhabit. Forget the image of a tiny speck. Our Milky Way is actually a swirling dance of billions of stars, a colossal spinning galactic disk. With a diameter spanning 100,000 light years, its vastness defies imagination. And hidden within this magnificent structure is a staggering number, an estimated 400 billion brilliant suns. Throughout human history, a fundamental question has always haunted us. Are planets rare gems, or are they a common part of the universe? However, thanks to the leaps and bounds of modern astronomy, aided by advanced telescopes like Kepler and countless other planet-hunting missions, the veil of mystery has been lifted. Planetary systems are far from exceptional. In fact, they appear to be a universal rule. Most stars in the cosmos host at least one planet orbiting them. If you do a simple calculation, the resulting number will astound you. Hundreds of billions of stars, which means there could be trillions of planets sparkling across our Milky Way. Among that colossal number, countless rocky worlds undoubtedly exist, some orbiting their host stars at an ideal distance, where moderate temperatures allow water to exist in liquid form, a crucial element for life. This is precisely the region astronomers affectionately call the habitable zone, or Goldilocks zone. Our Earth is fortunate to be perfectly situated within this ideal zone around the Sun. And it's thanks to this perfect arrangement that our blue planet can boast vast oceans, complex weather systems, and a stable environment, creating ideal conditions for life to flourish. Now expand your imagination. This favorable condition doesn't just happen once, but repeats millions, even billions of times across the vast expanse of our galaxy. Even if only a tiny fraction of these are truly suitable for sustaining life, the final number would still be incredibly vast. Even if just 1 in a million of these potential planets actually develops life, we would still have thousands of vibrant worlds in the Milky Way alone. And if an even smaller fraction of those planets were to eventually give rise to intelligent civilizations capable of creating advanced technology, let's ponder. If we only rely on the raw statistics, are intelligent civilizations truly a rare phenomenon in this vast universe? Logically, our galaxy should be teeming with life, but what's truly startling lies in the factor of time. The Milky Way, our cosmic home, has existed for over 10 billion years, while our solar system is only a mere 4.5 billion years old. What does this imply? In other words, the galaxy had billions of years of history before our blue planet even formed. And here's the crucial point. If intelligent life ever blossomed anywhere else in this vast universe, then many of those civilizations could have developed millions, even billions of years before humanity appeared. And this immense temporal gap holds a profound significance. Even if a civilization was just a mere million years ahead of us, a cosmic blink, they could have reached technological heights far beyond anything our imagination can grasp today. And given enough time, such an advanced civilization could easily expand from star system to star system, conquering neighboring regions of space and gradually spreading throughout the entire Milky Way. In summary, if intelligent life were even moderately common, then our Milky Way should be bustling, vibrant with countless activities. These civilizations would have emerged long before humanity ever stepped onto the stage of history. Their presence should be an unmistakable sign, evident in every corner. Yet when we gaze at the night sky, we find no clear evidence whatsoever of another technological species. No interstellar empire is apparent. No alien signal strong enough for us to detect. Only an ancient, silent Milky Way, sparkling with countless stars. And it is this terrifying silence that directly led to a question, both strange and famous, posed by the great physicist Enrico Fermi. If the universe is teeming with such boundless potential, then where is everybody? The great mystery we're about to dissect today, ironically, stems from something incredibly simple. Not from complex mathematical formulas or a massive scientific theory, but from a casual lunch conversation in the early 1950s. There, a legendary physicist, Enrico Fermi, was dining with colleagues at Los Alamos National Laboratory. Fermi was no ordinary scientist. He was one of the greatest minds in 20th century physics, a Nobel laureate whose contributions shaped nuclear physics, quantum theory, and even the first nuclear reactor. He was also renowned for his astonishingly sharp intuition regarding numbers and probabilities. It was during that fateful lunch conversation that the group began discussing flying saucers and the possibility of extraterrestrial life, a highly speculative, even somewhat jocular topic. Yet Fermi unexpectedly interrupted the conversation with a seemingly simple question. He asked, "So, where is everybody?" That was it. No complex formulas, no lengthy explanations, just 4 words. Initially, this question might seem unremarkable, but when you truly delve into it, it becomes a chillingly profound problem. Fermi's perspective wasn't based on UFO reports or science fiction stories. Rather, it was about pure mathematics and probability. Imagine, if our Milky Way galaxy contains hundreds of billions of stars, and if a significant portion of them possess planets, then the probability of life emerging somewhere must be incredibly high. And given enough time for evolution, some of that life would surely develop intelligence. Some of those intelligent civilizations would eventually develop technology, such as radio transmitters, spacecraft, and even the capability for interstellar travel. Imagine if only one civilization had mastered interstellar travel. Millions of years ago, their presence could have slowly spread to every corner of the galaxy. The thing is, they wouldn't need to rush. Even an expedition at a modest pace, just moving from one star system to a neighboring one, would eventually be enough to reach every part of the Milky Way. Because our galaxy is not only incredibly vast, but also incredibly ancient, spanning millions, even billions of years. Over such a long period, the expansion of a technological civilization seems inevitable. And this very fact leads us to a paradox. If intelligent civilizations are truly common, then our galaxy should already be teeming with their traces. We should have seen evidence everywhere, from emitted signals, passing spacecraft, to colossal artificial structures, or at the very least, the clear, undeniable sign confirming that we are not alone in this universe. Yet as astronomers diligently scan the skies, they haven't detected anything that could clearly prove that another technological species exists. Not a single extraterrestrial signal has been confirmed as real. No probes have ever entered our solar system, nor are there any traces of an ancient galactic civilization, leaving any clear mark across the stars. The universe, strangely, seems to be steeped in absolute silence. This profound contradiction between what we expect to find and what we actually observe is known as the Fermi Paradox. Although it bears the name paradox, it is not, in essence, a logical contradiction in the literal sense. Instead, it encapsulates a profound and perplexing question. Our galaxy seems to be teeming with ideal conditions for life to flourish, yet there is no clear evidence whatsoever of any other intelligent life out there. So the question still hangs in the air, just as Enrico Fermi posed it decades ago. If intelligent life is truly common throughout the universe, then why haven't we found any trace of it? One of the potential answers to this Fermi paradox is both surprisingly simple and harbors a disturbing truth. Consider this. Is intelligent life truly as common as we imagine? And perhaps just right planets like our Earth are a rare exception. Sounds hard to believe, doesn't it? Because looking around the universe, we see planets popping up everywhere. Astronomers have hunted down and found thousands of different worlds, orbiting distant stars, and all signs point to billions more planets hidden, waiting to be discovered. However, having a planet is entirely different from that planet having life. For an inert rock to transform into a cradle for complex organisms, a planet must meet the standards of a long and demanding list of requirements. It must park in just the right spot around its host star, not too close and not too far. So the temperature is perfect for liquid water to exist, the core element of life. If too close, the oceans would boil away. If too far, the planet would turn into a giant, cold, and sterile ice ball. This Goldilocks zone around each star is precisely the habitable zone where our Earth perfectly resides. But wait, a good location alone isn't enough. The planet also needs a truly stable orbit, one that doesn't wobble or change erratically over millions of years. And its parent star? It needs to be a gentle, long-lived giant. Some stars are too temperamental, frequently erupting violently, bathing nearby planets in deadly radiation streams, which can wipe out any nascent life. Then there are other stars that burn through their energy too quickly, fading away long before life has enough time to grow into anything complex. Our sun, fortunately, is an incredibly stable friend, expected to illuminate us for billions more years. But is that alone enough? Earth also has a giant bodyguard, our moon, which helps keep the planet's axial tilt stable. This stability plays a crucial role in maintaining sustainable climate patterns over millions of years. And let's not forget, our solar system also has giants like Jupiter, acting as protective gravitational shields to protect our planet from catastrophic asteroid impacts. Yet, there's a crucial factor we often overlook, a prerequisite that determines everything: time itself. Miraculously, on Earth, life emerged very early, right in the initial chapters of the planet's history. The oldest traces prove that the first single-celled organisms began their journey approximately 3.8 billion years ago. However, these primitive life forms were merely extremely basic cellular structures drifting in the ancient seas. And then an astonishing turning point appeared, or more precisely, an impressive process that consumed an enormous amount of time, stretching for nearly 3 billion arduous years. Throughout that period, life on Earth remained at a microscopic level. Bacteria and simple cells were the planet's sole inhabitants. For most of the planet's history, complex organisms remained a distant concept until a relatively short period on a geological timescale, spanning only the last billion years, when multicellular life truly exploded. From that moment, the evolutionary process accelerated dramatically. Plants, all kinds of animals, diverse ecosystems, intelligence, and ultimately, human civilization. When we reflect on this entire timeline, an astonishing truth becomes clear. It took nearly 4 billion years for life on Earth to transform from the simplest cells into a species with a technological civilization, capable of building rockets and radio telescopes. That period accounts for nearly 1/3 of the universe's total lifespan, a fact that suggests a worrying hypothesis. It's highly possible that many planets have generated life, but their environmental conditions could not maintain the necessary stability for a long enough time for that life to evolve to an intelligent level. Terrible catastrophes, such as supernova explosions, sudden climate change, or massive meteor impacts, could repeatedly reset the evolutionary clock. Imagine this. If this hypothesis holds true, then our Earth isn't merely one of many life-sustaining planets. In fact, it might be one of the exceedingly rare beacons of life in the entire vast Milky Way, where the current of life has resiliently persisted unbroken for billions of years, a span of time long enough for life to evolve from the simplest cells into complex civilizations. To truly comprehend Earth's extraordinary uniqueness, we must engrave a fundamental truth about the universe in our minds. It is anything but a peaceful or tranquil place. Within the confines of human perception, the night sky often appears as an unchanging, eternal tableau. Yet when viewed through the lens of cosmic time, we witness a universe rife with violence, chaos, and incessant terrifying events. Stars violently explode, colossal asteroids hurtle into planets, and even entire solar systems are completely restructured by immense gravitational perturbations, alongside space-spanning radiation bursts, carrying destructive power sufficient to obliterate an entire world. The universe is a constantly fluctuating entity, and most of the environments within it are utterly extreme. For life to evolve into a complex form, a planet must steadfastly endure for billions of years without being utterly annihilated. This might sound obvious, but in reality it's an incredibly challenging and extraordinary prerequisite. Let's delve into supernova explosions. When a massive star reaches the end of its life cycle, it can erupt with an unimaginable surge of energy, momentarily outshining an entire galaxy. Should such a cataclysmic explosion occur too close to a potentially life-sustaining planet, the immense radiation could strip away its atmosphere or utterly obliterate its essential protective ozone layer, leaving the planet's surface directly exposed to lethal ultraviolet radiation. A single nearby supernova possesses enough power to completely erase and reset a world's entire evolutionary trajectory. Next, we cannot overlook asteroid impacts. Even our own Earth has endured countless such events. Let's turn back the pages of geological history. Approximately 66 million years ago, a massive asteroid slammed into our Earth, triggering the mass extinction event of the dinosaurs. That fateful impact permanently altered the course of evolution, ushering in a golden age for mammals, and ultimately paving the way for humanity to rise and dominate the planet. However, that asteroid, despite its terrifying destructive power, could not completely eradicate all life. The current of survival resiliently continued. tiny microorganisms endured, vegetation gradually revived, and ecosystems were progressively rebuilt. Life on the blue planet persistently survived. Now, imagine an impact catastrophe far more horrific, a strike powerful enough to boil away entire oceans or rip apart the atmosphere, capable of wiping out every trace of life. If such an apocalyptic scenario had occurred at any point throughout Earth's 4 billion-year history, then Earth's evolutionary saga would have ended permanently before any intelligent life form had the chance to be born. The miraculous thing is that catastrophe never happened. Furthermore, our sun also possesses extraordinary stability. While many other stars frequently undergo violent fluctuations, releasing energy bursts and deadly radiation, although the sun does experience certain changes over time, it has never been harsh enough to scorch Earth throughout billions of years. It has maintained a continuous and stable energy source, just enough to nurture life, but never so violent as to destroy it. And our position in the galaxy might also be a stroke of luck. Our Milky Way galaxy contains regions where stars are densely packed, where supernova explosions occur more frequently, and gravitational disturbances are stronger. Coincidentally, Earth fortunately orbits within a relatively peaceful region of the galaxy, far from the chaotic galactic center, where conditions are exponentially harsher and more dangerous. All these seemingly random factors, when combined, have created a truly extraordinary outcome. Imagine an unbroken stream of life, diligently persisting for nearly 4 billion years. This relentless persistence is the foundation. After all, the grand process of evolution cannot be completed in the blink of an eye. The miraculous journey from the simplest cells evolving into complex organisms, and then the pinnacle to achieve intelligence, demands long drawn-out geological eras. Just one small interruption in that flow, the entire process would have to restart. So perhaps the reason we've never encountered countless extraterrestrial civilizations isn't because life never took root, but perhaps it has started many times, yet almost always been cut short before it could develop to the threshold of intelligence. If so, our Earth isn't merely lucky, but rather incredibly, unbelievably lucky. Another explanation for the Fermi Paradox, also very thought-provoking, though less dramatic, it carries profound implications. Intelligent civilizations may indeed exist, scattered throughout the galaxy. But the immense distances between stars are simply too vast for us to detect them. Cosmic space, after all, is a vastness beyond human comprehension. Even our closest star system, Alpha Centauri, is over 4 light years away. This means that the light we observe from it tonight actually departed from that star over 4 years ago. To travel there with our current spacecraft technology would take tens of thousands of years. And remember, Alpha Centauri is already our closest, quote, neighbor. Now try to imagine extending that distance to the scale of the entire Milky Way. Our galaxy has an estimated diameter of 100,000 light years. Between most stars are vast, empty cosmic spaces. Even when traveling at extraordinary speeds, conquering those distances remains an enormous technical challenge. For that very reason, advanced civilizations may still exist. Imagine a civilization that, even if trapped within its own star system's gravitational well, could still achieve technological pinnacles. They could build colossal telescopes, even launching their first messages into the vast cosmic expanse. However, this is where physics intervenes. Those signals, no matter how powerful, quickly dissipate. Radio waves, by their very nature, spread out in all directions. The farther they travel, the more their energy disperses, becoming increasingly diluted. By the time they reach the threshold of a neighboring star system, they may have become too faint to be detectable. And ironically, a similar challenge plagues interstellar travel. According to the laws of physics as we know them, traversing the void between stars is not impossible. However, it is an incredibly arduous task. To build a spacecraft capable of enduring decades, centuries, or even millennia in deep space would require a level of technology far beyond anything humanity can currently conceive. Even if we could realize such engineering marvels, the cost in resources and effort would likely be astronomical. A civilization might be able to explore nearby stars, but would realize that expanding across the entire galaxy is impractical. If this scenario holds true, our Milky Way could indeed be home to countless intelligent species, but each separated by such immense distances that they would rarely, if ever, have the chance to encounter one another. Entire civilizations could rise and fall without ever knowing that other civilizations exist elsewhere in the same galaxy. However, this explanation still has a significant flaw. Even if traversing the stars in person is a monumental challenge, other methods exist for a civilization to explore the entire galaxy. Instead of risking living beings across the harsh interstellar void, they could choose to send machines. Machines don't require oxygen, food, or comfortable living conditions. They can resiliently endure endless journeys and operate reliably for centuries, provided they are optimally designed. Imagine this. What if these machines, upon reaching an alien star system, were capable of self-replication? Their expansion would then occur at an astonishing speed, far beyond imagination. This very idea gave birth to one of the most controversial and profound arguments within the entire Fermi Paradox. This argument posits that if any civilization had ever reached a sufficiently advanced technological level, then the entire Milky Way galaxy would soon be teeming with their countless machines. Yet strangely enough, as we observe the vast universe, there is no trace whatsoever to suggest this has ever happened. It is at this crucial juncture of the mystery that many scientists have shifted their focus, posing an entirely new question. Instead of wondering if civilizations are capable of conquering and traveling across the galaxy, we might ask a more fundamental question: do they actually need to? Imagine this. You are a member of a civilization with superior technology. Your scientists have completely mastered artificial intelligence, robotics, and space engineering. Instead of risking fragile biological beings on perilous interstellar journeys, you decide to deploy machines. These machines are autonomous, compact probes, specially designed to explore nearby star systems. Now imagine we bestow upon these probes another extraordinary ability. When they arrive at a new solar system, they can utilize the readily available local resources, from asteroids, rocks containing precious metals, or even planetary debris, to replicate themselves. As soon as complete copies are formed, each one will continue its journey to another neighboring star system, and so this cycle repeats. What you have just created is what we call a self-replicating probe, often known as a von Neumann probe, named in honor of the brilliant mathematician John von Neumann. Imagine a bold idea, a concept that has made scientists ponder: machines that can self-replicate. These self-replicating machines hold extraordinary potential. Just imagine if our civilization were to successfully launch just one probe. That probe would soar to a nearby star system, and there it would create two perfect copies of itself. These two new probes would then continue their journey, each one duplicating itself into two. In the blink of an eye, you'd have 4 probes, then 8, then 16, then 32, and so on. This is the power of exponential growth. The marvel of exponential growth is this: it starts seemingly slow, but then explodes with incredible speed. Even if each probe took thousands of years to traverse vast space and complete its self-replication process, their numbers would still skyrocket astonishingly on a cosmic time scale. In a relatively short period, in just 10 to 100 million years, a mere blink of an eye in the universe, these machines could have spread from one star system to another until they reached every corner of the Milky Way. That might sound like an eternity, but considering the entire lifespan of a galaxy, that number is truly just a tiny moment. Remember, our Milky Way galaxy has existed for over 10 billion years. So 100 million years is just a blink compared to that history. And this leads us to a truly astonishing conclusion. If just one civilization in this galaxy ever developed self-replicating technology, millions or even billions of years ago, then their machines would surely have spread everywhere. They would be swarming the Milky Way. These probes could be quietly orbiting countless stars everywhere. Some might even be silently hidden right within our own solar system, observing planets like Earth. Yet once again, as astronomers diligently scan the skies and meticulously examine the nearby cosmic neighborhood, they find no clear evidence whatsoever of the existence of these self-replicating machines. Look at this vast universe, a chilling truth emerges. No alien probe has ever visited our world, nor are there any grand artificial structures orbiting distant stars. There is no clear evidence of an ancient technological civilization that once flourished in the cosmos, one that conquered and explored this galaxy long before humanity. This strange absence only thickens the veil of mystery, because if even a single civilization had the capability to fill the entire galaxy with their machines in a relatively short period, and considering our galaxy has existed for billions of years, then finding no trace of those machines whatsoever is truly unsettling. One possibility is that perhaps no civilization has ever reached such a high level of technological advancement. Or perhaps something terrible stopped them before they had a chance to develop. However, there is another possibility, one that is both fascinating and terrifying. Perhaps this galaxy isn't as empty as we imagine. Perhaps advanced civilizations are out there, silently observing. They are listening, perhaps even exploring, but actively choosing to maintain absolute silence. This profound idea is sometimes known as the dark forest hypothesis. The name comes from a very simple yet haunting metaphor. Imagine you are walking alone in a pitch-black forest at night. You know that there might be other predators lurking somewhere among the dense foliage. You can't see them, and you have no idea if they are friend or foe. In such a life or death situation, the safest strategy is certainly not to shout and reveal your location. Rather, it's to remain absolutely silent and hide yourself well. When this logic is applied to a galactic scale, it becomes indescribably terrifying. If intelligent civilizations truly exist, they might deduce that other civilizations could pose an immeasurable danger. Because any species capable of interstellar travel could also possess technologies powerful enough to destroy entire planets. Imagine a scenario. What if publicly broadcasting our address in the universe conceals unimaginable dangers? A civilization that prioritizes its survival above all else might have concluded a golden rule: stay in the shadows, remain absolutely silent. Assuming every highly developed civilization has learned a similar lesson, then our galaxy could be teeming with intelligence, yet shrouded in an eerie silence. From our vantage point, it seems everyone is listening, but no one is speaking. If viewed this way, the universe's silence doesn't prove our solitude. On the contrary, it implies that all civilizations have learned a common lesson, that revealing their existence might be the riskiest action they could ever take. What makes this hypothesis particularly intriguing is how humanity has behaved almost in opposition to it. Since the mid-20th century, we have continuously broadcast radio signals into space. From television programs and radar systems to powerful communication networks, all have inadvertently or intentionally leaked the electromagnetic waves beyond Earth. Some scientists have even actively sent messages aimed at extraterrestrial civilizations. A prime example is the famous Arecibo message, broadcast in 1974, directly targeting a distant star cluster. This was a deeply symbolic effort to declare humanity's presence to the entire universe. Spacecraft like the Voyager probes also carry plaques and golden records inscribed with information about our blue planet, along with the imprint of humanity, meticulously crafted in case another civilization accidentally discovers them. In short, humanity has no intention of hiding. On the contrary, we have been eager to send greetings. However, perhaps more advanced civilizations would behave entirely differently. Perhaps with their superior intellect, they chose the most cautious path, realizing that their survival depended on their ability to remain completely hidden within the vastness of the cosmos. If this hypothesis is true, then the silence enveloping space might not be a mystery at all. Instead, it could be the echo of countless civilizations that have actively chosen to remain absolutely silent. Among the myriad explanations for the challenging Fermi Paradox, one hypothesis stands out, carrying a chilling truth. This is the concept of the great filter. This idea, though simple, holds astonishing depth. On the long journey from the most rudimentary chemical reactions to the formation of a superior interstellar civilization, there exists an enormous obstacle, a threshold that almost no life form can cross. This fateful obstacle is the great filter. To truly grasp its meaning, let's envision the sequence of consecutive events absolutely essential for a civilization like ours to emerge. First, a planet must form around a star. Next, chemical reactions must miraculously arrange themselves to create the first self-replicating molecules. Over billions of years, these molecules must gradually evolve, transforming into the first living cells. From single-celled organisms, life must develop into more complex forms. Intelligence must blossom, and technology must be born. And finally, that technological civilization must demonstrate its sustainable existence, enough to venture beyond its planetary cradle, reaching out to conquer galaxies. Each link in this chain of events carries an extremely low probability. If just one of these stages is exceedingly rare, then the number of civilizations capable of reaching the final threshold will become incredibly small. There's a comforting possibility. The great filter lies in our distant past. If so, humanity has successfully overcome the most arduous challenges. Perhaps the origin of life is an exceedingly rare event. Or perhaps the leap from simple cells to complex multicellular organisms almost never occurs in the universe. Is the rise of intelligence merely a rare cosmic accident in the vast universe? A unique one-time event among countless planets? If the great filter lies in our past, then perhaps we are simply incredibly lucky. As life on Earth miraculously overcame a series of seemingly impossible evolutionary hurdles, challenges that almost no other civilization in the universe could surmount. However, another far more chilling prospect exists. The great filter might be awaiting us in the future. If so, other civilizations might frequently reach a similar level of development as humanity has today. They flourish in science, industry, and technology, creating colossal energy systems, intricate communication networks, and even advanced weaponry. But then, before they can venture beyond their planetary cradle, a terrible catastrophe strikes. It could be self-destruction through an all-out nuclear war, or climate imbalance devastating the ecosystems they depend on, or accidentally unleashing deadly biological weapons, or creating artificial intelligence beyond their control. Technological power might grow exponentially, but wisdom or political stability fails to keep pace. If this scenario repeats often enough, then most civilizations will self-destruct before they can become interstellar species. They are merely fleeting sparks in the cosmic flow of time, burning brightly for a moment, then forever fading into oblivion. This possibility truly gives us pause, because similar dangers are already looming right before our eyes. Today, humanity holds nuclear weapons, powerful enough to wipe entire continents off the map. We are facing severe environmental challenges, threatening global stability. Emerging technologies, from groundbreaking biotechnology to artificial intelligence, promise a bright future, but also harbor immense risks if misused or poorly managed. Are we approaching the threshold of the great filter, an existential barrier that every civilization must confront? If this hypothesis is true, then the terrifying silence of the universe isn't necessarily proof that intelligent life is rare. Instead, it could be a grim warning. Advanced civilizations often tend to self-destruct. Before we can reach for the stars, one final, less discussed possibility remains. A possibility that many scientists quietly ponder when confronted with the Fermi Paradox. This isn't the most shocking explanation, nor is it particularly comforting. However, it is the simplest explanation. And perhaps the real reason the universe remains shrouded in baffling silence is precisely because truly intelligent civilizations are exceedingly rare. So rare, in fact, that in an entire vast galaxy like the Milky Way, perhaps only we exist. However, this idea doesn't negate the possibility of life existing elsewhere. In fact, many scientists believe that single-celled life, like bacteria or primitive life forms, could be common on countless planets. Even within our own solar system, there are still potential locations for microbial life. Mars, for example, once had vast rivers and lakes. The moons Europa and Enceladus, meanwhile, conceal vast warm oceans deep beneath their icy shells. Even more distant celestial bodies like moons and dwarf planets could harbor hidden pockets of liquid water. In summary, microbial life might be a widespread phenomenon throughout the universe. However, the leap from simple bacteria to complex life forms is an extremely rare event, even on Earth. One of the greatest turning points in evolutionary history was the emergence of eukaryotic cells. These are cells possessing complex internal structures and a distinct nucleus, and they laid a solid foundation for all the complex life we see on the planet today, from animals, plants, fungi, to humanity itself. Imagine a truly unique event, a historical moment that, as far as we know, has only ever happened once. Across the endless tapestry of life on this blue planet, all the complex forms we see today all share a common origin, an extraordinary, singular, evolutionary leap. But what if such a monumental shift demanded an incredibly random sequence of events, an almost unimaginable alignment of factors? Would complex life then be exceedingly rare, even on worlds where simple life has already taken root? And if complex life is rare, then intelligence, sentient life, might be an even rarer gem. From that perspective, a galaxy ablaze with billions of planets could still be a vast emptiness, home to very few civilizations, perhaps even less than one on average. Some galaxies might be utterly devoid of intelligence, while others, if fortunate, might host only a single intelligent species that briefly flickers into existence before fading away. If this scenario holds true, then our Milky Way might just be a vast cosmic ocean, teeming with stars, planets, and microbial life, yet home to only one civilization. A civilization capable of pondering the universe's very existence. This hypothesis carries a profound implication, an immense responsibility. If we are indeed the sole intelligent voice in this vast galaxy, or at the very least one of a select few, then the destiny of intelligence across the entire Milky Way could entirely rest on what unfolds right here, on our tiny planet Earth. Our planet would no longer be merely a world with distinct life among billions of planets. It would become an invaluable treasure, something beyond all imagination. It would be an oasis of consciousness, a meaningful beacon in the vast cosmic ocean. And that profound realization places an extraordinary burden of responsibility on each of us. For if we were to destroy our civilization through war, environmental collapse, or simply through indifferent apathy, we would not merely be closing a chapter in human history, but could also be permanently extinguishing the only flame of intelligence in a galaxy ablaze with 400 billion suns. Of course, this remains merely a scientific hypothesis, and scientists with their relentless spirit of discovery would be absolutely thrilled if one day it were proven wrong. What if one day we receive a signal from a distant civilization or find undeniable proof of extraterrestrial life? That would undoubtedly be one of the most brilliant milestones, reshaping the entire scientific history of humanity. Yet up until this very moment, the terrifying silence of the vast universe presents us with a haunting question, an intractable paradox. Is it possible that the universe isn't teeming with civilizations as we've always imagined? Is there something waiting for us to discover? Or perhaps the universe has patiently awaited a single civilization that had enough time to flourish brilliantly and reach out to the distant stars.